In this question, we're going to have a look at a pretty difficult discriminant type question. So first of all, it tells you that this quadratic has two distinct real roots. What we know about two roots is that b squared minus 4ac, the discriminant, is actually bigger than 0, where there are two roots. We also know all quadratics are in the form ax squared plus bx plus c, where a is the coefficient of x squared, so it's a number before x squared. In this case, that's 1. B is the coefficient of x, which is n plus 1. And c is just that last term at the end, which is 3 minus 3n. Once we have values of a, b, and c, we can put them into the discriminant and set that as being larger than 0, and then solve the inequality that comes from there. Let's do that. So we have b squared, which is n plus 1 all squared, minus, I like to put everything in brackets, so 4 in brackets multiplied by a, which is 1, multiplied by c, which is 3 minus 3n, is all larger than 0. Now, when you square something, that's essentially the same as multiplying it by itself. So I'm going to write this out as n plus 1, and then 4 times 1 is 4, and then in brackets 3 minus 3n is all larger than 0. N times n is n squared, n times 1 is 1n, 1 times n is also 1n. So those would add to give you 2n. 1 times 1 is 1, minus 4 times 3 is minus 12, minus 4 times minus 3n is plus 12n. And that's all larger than 0. When you collect like terms, 2n plus 12n is 14n. So we can write after that n squared plus 14n. And then adding the whole numbers, 1 take away 12 is minus 11, is all larger than 0. Now, if you try factorizing this, you probably have realized already there are no whole number roots. Instead, we have to use the quadratic formula. So minus b plus or minus square root of b squared minus 4ac all over 2a. And when you do that, I did it beforehand, we get n is equal to minus 7 minus 2 root 15 when you use the minus part of the equation, and n equals minus 7 plus 2 root 15. Now, when is this quadratic, which has these roots, larger than 0? So from there, I'd recommend you draw your own little quadratic. One of the roots is minus 7 minus 2 root 15, and the other is just above where x is 0, so minus 7 plus 2 root 15. If we draw a brief quadratic representing what this looks like, we can note that this quadratic is larger than 0 when the curve itself is above the x-axis, because above the x-axis is when the curve has a positive y value, which is above 0. So we say when n is less than minus 7 minus 2 root 15, because when n is to the left of this, that's when the quadratic is bigger than 0. Or when n is larger than minus 7 plus 2 root 15. Those are the two inequalities, the two regions, where this quadratic is larger than 0. And they are the set of possible values of n for which this whole quadratic in the beginning has two real roots. Hopefully that all makes sense. Sorry if I sound a little out of breath, I kind of ran here. But be sure to like the video if it helped, and be sure to subscribe. I'll post more content like this very soon.